Okay. Well, good morning, everybody, and welcome to today's Data Science Education webinar on May 8th. This webinar is being made available through the Concord Consortium, which is a nonprofit education technology laboratory based in Concord, Massachusetts, and Emeryville, California. You can learn more at our website at concord.org/meetup. I'd like to introduce you to our facilitators, Christine Voyer, Molly Auclair, and Meggie Harvey. During today's webinar, facilitators will be sharing their work with us about data learning through citizen science. I'll let our facilitators introduce themselves about that in just a minute. A recorded version of this webinar will be made available on YouTube. We'll email you details about through Eventbrite after the event. If you're comfortable sharing your name and face, please turn on your web camera during the webinar event so that we can see you. I'd also like to emphasize the format of this webinar is participatory by design. That means that we're all going to work together to discuss the conversations, the connections, and activities that we're going to go through today. I'll facilitate the web questions that you have on chat and also on video, and I'll also field the text-based questions on Zoom chat. For those of you just joining us, welcome to our webinar. Our speakers are Christine Voyer, Molly Auclair, and Meggie Harvey, who will be speaking about data learning through citizen science. I'll let you three take it from here.
All right, great. Thanks, Natalia. While Meggie is getting our presentation up on our screens, I'll just mention that Molly, Meggie, and I all work, and I'm Christine. We all work at the Gulf of Maine Research Institute in Portland, Maine. It's fun to see Tom Farmer, our former coworker, in the webinar. And just maybe a little about our backgrounds. We all come here with some combination of work in science and STEM education and research or other varied experiences. So we're bringing those to the table. We're all very much practitioners and not academics or researchers of what we're doing. So that's us. And you can see a view of our building here in Portland, Maine on the slide. And it's a lovely day, kind of like that here today. So we're really excited to share our work today. And having sat in on some of the webinars with the folks who have been delivering them, we feel, I think, really honored to be in that company. And so much of the work and the folks presenting at these webinars have been people that are doing work that's inspiring the work that we do here. So just wanted to give that little shout out. Our plan for our time together is that, well, we had two goals. What are they? Oh wait, I can look here. Sorry, forget it. I'm good. So our goals were that you would understand the context and the conceptual framework for the work we're doing with kids and classrooms across Maine in the context of citizen science and data, and that you would identify our learning progression that we're using as a model that you might use or take things away from in the work that you're doing. So I'm going to tell you a little bit about our program and the work we've been doing, a little bit of kind of backstory, and more on our current design work. And then we're going to share and model the data learning progression that we've been using in our curriculum and teacher professional development. Meggie's pulled some awesome examples from classrooms of student work that you are all the first to see outside of our team. And then we thought we'd have plenty of time for discussion. So that's our plan. So I'll just get us started. So again, like I said, Molly, Meggie, and I all work here at the Gulf of Maine Research Institute in Portland, Maine. And we all work on our Vital Science program, which is a citizen science and science education program. It was launched more than 10 years ago, and it was launched with the focus on invasive species in Maine, specifically focused on engaging classrooms in the research questions and the monitoring work happening around invasive species. We have citizen science and species experts, and includes over 400 trained teachers, and there are thousands of students. We estimate about 3,000 students each year are participating in the program. And that community has contributed over 10,000 observations of presence-absence data all over Maine. And this map gives you a glimpse of the data that's being collected. And since the launch, the program has also grown and evolved in both organic ways and really intentional ways. The goal of the program, the overarching goal, has always been to both contribute to scientific knowledge through citizen science and also support science learning by engaging kids across Maine in authentic science investigation. So we've always held those two as really equal goals of the work. And this notion that citizen science is a powerful context for authentic science inquiry for kids has been an underpinning of the program for that duration. And we, in order to try to achieve what we see as the potential of that context, we've tried a lot of different things. We've done a lot of experimenting, and we've learned a lot. And in particular, especially in the last 5 or so years, work with data has been a key theme of that. If you attended the recent webinar by the folks from BSCS and FieldScope, they talked a lot about citizen science, what it is, and the opportunity to engage learners in data in the citizen science context, thanks to their firsthand experience with data, and we'll talk more about that in our presentation here. We wanted to, oops, that's an extra slide. We wanted to also mention that some of the things that have been foundational to our work around data have included Kim Caston's data learning trajectory. She did one of these webinars also recently, the GAZE framework, and which I think has been mentioned in the webinars. And then Friday Institute's MOOC on teaching through data investigations. Those are just things we wanted to give shout outs to that have really helped us in our work. As we sort of talk more about our design work that we're getting into, a quick mention that a lot of this is around our technology platform, and it's also involving our curriculum work. So those are sort of two things that are both happening at the same time. And a major shift around both of those pieces is around a shift in focus to climate-driven ecological change. So away from specifically invasive species to this broader question of how are ecosystems changing in our region, and how might climate change be driving some of that change. So on the screen right now is a screenshot of our old website mission landing page. And then just to know also, we currently are kind of in between technology platforms. So you won't be able to access the Vital Signs Maine website right now, but by the fall we'll have a new one up and running. We also have some beta sites, a beta site that we can share with folks who are interested. So these this screenshot of our packet. In the past, we had a lot of species that participants could contribute data on, a lot of missions that they could participate in. And in our new platform, we're going to narrow that down to a more reasonable number of classroom targeting missions. There will also be more community-focused missions. And again, all focused on that regional ecosystem change that I mentioned. And part of that narrowing down is to really build more robust data sets around each of those missions, really focus our community so that we get a lot more data around each one. So with fewer missions, we've been able to wrap a full curriculum unit around each mission, and that's our plan going forward. But each curriculum unit really follows a similar path and has a similar outline. So this slide just shares that outline with you. We have 4 parts to the unit, and we start in each case with building background knowledge, which we see as being really critical to the work moving forward, including the work with data, as well as students really understanding the context and the reasons why they're doing the work they're doing. And then students build the skills to collect and contribute data, and then they go out and do that. and then they work with the data, and then lastly, they communicate findings, which I'll just note is a space we've left a lot more open-ended so that teachers can kind of pursue whatever creative means for sharing that they want to do with students. So that's the overall outline of our units. And yeah, and so just to note that pulling through all that, I would say are these ideas around both and the importance of background knowledge, working with the data, and always kind of connecting back to their overarching question. And that those three things and more probably are pulling through that whole experience. So as I mentioned, with this focus of missions, we are hoping to build much more robust data sets to give classrooms and scientists and other partners a lot of data to work with. In our work with teachers, we've found that teachers don't have a lot of comfort or exposure to tools and ways of working with data kind of beyond bar graphs. It's a very bar graphs are a very comfortable space, and many teachers aren't comfortable going beyond that. Both the Common Core standards, the NGSS, and I think general interest from the teachers we work with drive a demand for working with data in deeper ways. But we found that teachers need a lot of support to get there, so we've really focused our curriculum and PD to provide that. So the next slide. So the first place that we're providing that support is in the way we've redesigned our missions, and that starts with a guiding research question. We've developed missions with research questions that are really juicy from the beginning, require thinking about data, and go beyond the presence-absence data that we historically collected. The questions might be the exact questions the partner scientists are interested in, but they might be more kid appropriate and but still parallel and get the scientists the data that they need and want. And the new platform, because we're going beyond presence absence data, we're developing a platform that supports data coming in, different types of data for each mission or project, and where each one is derived from its own unique protocol. So all the missions have really different protocols and data types that are being collected. And from the get-go, we plan for these mission pages to be a space that students interact in and explore, and that includes having visualizations teed up of the relevant data for the mission, so that from the beginning they're interacting with data, they're seeing data as a critical piece of this experience and how they're going to help answer the questions. So again, just sort of overall themes in the curriculum is that to help teachers deepen the work around data, we're seeing it as sort of three strategies. And first, as I mentioned, is engaging with data from the beginning of the experience, like through this mission page, and then engaging learners in a data learning progression or pathway from thinking about their individual data point to a full citizen science database. And then through that progression, really building a foundational understanding of variability and the concept of variability, which through our work is something that's emerged as missing and foundational. So that's been our focus. Is it still me? Okay. So that learning progression that I mentioned is summarized here. So we're starting with kids collecting data in their spot, depending on the protocol. It might be a specific tree or a quadrat on a transect, but that's their spot that they understand, that they get to know really well out in the field, and that they record on their data sheet. And then back in the classroom, after thinking more about what they saw and what they collected, they compare with another classmate who looked at a different spot. And then that moves into describing the full class, or looking at the full class data set, and then moving into the full citizen science database. Anything else I need to say? Again, through that progression, we're pulling on and adding to their background knowledge. They're thinking about variability in a way that grows in complexity. And again, just to reiterate that we model this in our PD with teachers, so that they're experiencing this progression and thinking about ways to frame it and talk about it before they go back to the classroom.
Christine, what range of grade levels are you working with?
Oh, good question, Bill. We primarily work with middle school teachers. I would say 6th through 8th really make up the bulk of the teachers we work with, but we don't have like barriers around that. Really, any teacher that signs up and wants to come and use the curriculum, we welcome them. And so I would say somewhere between 50 to 70% of our teachers are middle school. And some then in the lower grades and some in high school as well.
Mm-hmm.
Is it still me?
Yep.
Oh, gosh. So we wanted to spend a chunk of time with you guys actually going through the learning progression and seeing the model kind of in a way that we might do it with teachers, but virtual versus in person. The mission that we're sharing, the mission and the curriculum were piloted this past fall, and we also have more students piloting it this spring. And it's not totally new. We've had a similar mission going on in our old system, but again, since we're enhancing our capacity around the types of data that can be collected, it looks new and different. So I am going to hand things off. And just as a note too, there'll be a lot of places where we're asking people to use the chat window to capture thinking throughout. And so I'll hand things off to Molly.
Hello, I'm Molly, and as Christine mentioned, we're going to model this progression that she's been talking about using an example of one of our recent pilot missions, and the mission is guided by the research questions that you see on the screen in front of you. So how do abundances of native and invasive crabs compare up and down the coast? Is the proportion of native versus invasive changing over time in relation to climate change? And where will native and invasive crabs be most abundant in the future? So we're grounding the work with data within a context that connects to students to their recent experience and data that they know. And this will be our first experience, or all of us, our first experience today, and a launch pad for understanding and discussing natural variability. So in our curriculum, we ask students to start by considering the data that they collected. So what do the numbers they wrote down represent? What was going on in their spot? So we're going to have all of you collect some data. So imagine that you're here in this rocky intertidal zone that you see in the picture. You've laid down your transect, placed your quadrat at the meter mark along the transect that was randomly assigned to you. And now you'll see on the screen in a moment one quadrat and the data that was collected. So we'd like you all to just take a minute to review this data that's on the screen and think about, what was it that you uncovered within your quadrat? Just take a minute to read it over and think about what you saw. Okay, so now we're going to switch to a different quadrat. So we'd like you to take a little more time now with this observation that's on the screen and think about what is similar to the observation you just looked at and what's different. And this is where we'd like you to use the chat box to just take, send us little notes of what you think is similar and what you think is different. So we'll take a few minutes to do that, and as things are coming into the chat box, I'll call them out so everybody can hear them. Right, so the second quadrat seems to be wetter than the first quadrat, was an observation that Natalia saw. Seems to be less seaweed here than in the first one. different location, reversing falls, okay, which is an interesting feature of the site. And those reversing falls a similarity or a difference? Seems to be lots more crabs and a lot more green crabs. Still no other kinds of green crabs other than green crabs. And I guess the reversing falls was a difference. Thank you. But yeah, we're seeing more green crabs in this second one. Larger green crabs, so the size is different. First quadrat is darker than the second one. Okay, so different light levels. These are all really great observations. Give a couple seconds to see if there's any last ones coming in. All right. Oh, you're typing. 15 crabs visible in the quadratic picture. Oh no, good question. Usually, well, it's possible that they're there, but the students collecting the data will take a picture of where their quadrat is. So this may have been taken before they started digging in through there to get their crabs or after. It's just to give the species experts an idea of, you know, if the students are saying it's a rocky intertidal or they're saying that it's mostly seaweed, they should be seeing that in the picture as well. Good question. Same latitude was a similarity. Okay, great. So as you can tell by all the comments you've been leaving, you were all really easily able to identify ways that your data, so the first quadrat, versus the other point that we're seeing here, how they varied naturally. So natural variability is what we were discussing here, and we didn't talk about human error, right? So this is something that many classroom conversations about variability tend to focus on. So the key points here have been to have a really focused conversation around one spot, your spot, and what you noticed. When a student collects data and then discusses it, they're really keenly aware of what the data point represents. Then, having you compare your data with somebody else's in the same area, we were able to really focus on natural variability of our data so far. And having this discussion in the context of our research mission allows for the data to connect directly to an experience that we've had. So we tried to, you know, create that experience for you in the virtual space. And now we're gonna use, we're gonna kind of continue with our exploration of data into our class data set. So this class data set, so as a context to really dig deeper into the concept of variability, we're building on our understanding and our discussion around variability. So what does variability look like in a data set across a transect? And what are some informal ways we can talk about variability? So we're going to avoid jumping into formal statistical language, and instead we're going to focus on describing the shape of the data. So we're going to throw out some questions about the data, as we do, we'd like you to type your responses in the chat box. And the challenge here that we're posing to you is to see what you can do without using your formal data or statistical language. So we'll start with the first one. So what are the highest counts that you're seeing here on your screen? What are the lowest counts? So use the chat box. Okay, 0 to 3, 10 is the highest, 1's the lowest. Great. Okay, are there data spread out, are the data spread out evenly, or are there any clusters of data? There's some clusters, there's clumps, good words. Clusters at 6 and 7, very specific, good, nice. Okay, so a question here, so not really clear about understanding the 0 to 3 as a range of counts. Okay, so maybe 0 to 3 as minimum, I think. So the question was,
I think a commenter was saying that for any number of crabs that was counted in a quadrat, it occurred either 0, 1, 2, or 3 times. Mm-hmm. I think that's what that comment was.
Okay, yeah. And there's a good kind of clarifying question here. We didn't actually orient you to the graph and what was showing. So this is a dot plot showing the number of crabs within a quadrat.
And we would have students place the dots on this dot plot based on the data that they collected, using their own little sticky dot for their own data point.
Right. Good questions here. So next question I might ask you after talking about the spread. So we've highlighted some clumps and everything. So what might explain some of the natural variability that we're seeing here? And you can base that on your experience with the two quadrats that we looked at. Tide, okay. It would be disturbing if someone reported half of a crab, but yes, predation. Good observation. Vegetation present, yes, definitely. The difference in vegetation between quadrats. Any other ideas to explain some of the natural variability that we're seeing? Distance from the water, closer or further from, okay, so those are two comments. Infighting among crab individuals. Ooh, nice one, S. Kern. Collection methods, great.
And so just to know that these are all collected with following the same protocol, right? But different students maybe
the depth of digging.
Yeah.
Right, or collect, yep, okay. Great, so these are some great explanations of natural variability. How about, so are there any points that stand out in our class data set so far? They were allowed to dig, yeah, so they were able to move, not pull anything out, but so move seaweed around, look underneath it. Yeah. All right, the 10 seems to stand out to everyone. So 10 green crabs within a quadrat. Okay, so this was just to model a few kind of questions that we could ask of this data. And again, really focusing on non-technical language. Again, so right now,
just a quick note when you're thinking about points that stand out and any of the numbers and what they might mean, in that conversation with students, you're going to want to really draw on their background knowledge and the knowledge that they're building. And I only note it because 10 crabs in a quadrat here is actually wouldn't be surprising. So, and students will have built a lot of knowledge around green crabs to where that you could draw on that in the context of having a conversation about is something an outlier or not.
Mm-hmm. Definitely, good point. So right now with students, we're really focusing on describing the shape of the distribution. That's what we were talking about with the class data. And this gives students the tools to compare to other distributions. And we work with teachers across a range of grade levels, as Christine mentioned. And some are working to have students use that for formal statistical language and values that help describe the distribution. So like range, mean, median, mode, standard deviation. So we share that even for those teachers and those students, the underlying conceptual understanding is often missing. And starting with this informal language will really help students understand what the formal statistics describe. And then they'll be really excited to have these formal statistical tools to help them in the future. And so you're seeing some student work here in front of you. And we have in our curriculum this structure to guide the questions around looking at class data and allowing students to really highlight those differences that they're seeing. And there you go.
And just a note about this student sample is that the students were looking at their own class data, so it's not necessarily the distribution that we were looking at on the last slide that they're describing here.
Right. So we could imagine, and good question, so coming in through the chat box, that students would have the same conversation about the green crab data as they would with the Asian shore crab data that they collected and the native crab data. So they would have that informal conversation around variability and shape and distribution with those three different species, and depending on where you are, where you're collecting data, those dot plots are going to look very different.
Mm-hmm. So at this point, we would revisit our investigation questions of how do our native and invasive crabs compare up and down the coast, and our abundance is changing over time and in relation to climate change. And we hope that from this engagement with the class data, that students are then sort of asking for more data to be able to address these questions. So we see from a lot of student responses that they are indeed looking for more data, looking for something beyond their own classroom. So then that gives us the opportunity to open up to a larger citizen science data set. So students have developed language and strategies to support understanding and describing variability and small distributions. So they're primed for this larger data set. The data set has meaning and context. They've been out, they've been collecting the data, and we've repeatedly had students connect back to that experience with the data. And so they're able, so we see this as supporting them in moving from this very concrete experience to the data they're familiar with and concretely constructing these graphs, to then data that is farther from their own individual experience and into this context of working with data on their computer, which is even sort of less concrete than constructing their dot plot by hand. So the data set that we're looking at here, it was collected from 4 schools from our fall pilot. So only a small subset of our pilot teachers participated in this particular mission. So this is from those 4 schools. The data has not been moderated, and our review process is still being developed on our new technology platform. So you'll notice that there is some messy data in here.
And so that's just a note about, in engaging in a citizen science project. For folks who aren't maybe as involved in citizen science, there are experts and scientists and researchers behind each of the missions who are engaged in reviewing and sort of filtering the quality of the data. So that's just what Maggie's noting, is that we, on the new platform, haven't developed that process yet. So this data hasn't been cleaned.
All right. Oh, whoops, sorry. I need to go back. There we go. All right. So even from 4 classrooms over 1 season, you can see that we're starting to develop a decent sized data set here that students can dig into. But before we get them to the point where they're making meaning from the data, we know that they need a little help figuring out this platform and this new space and the tools. So we developed our own strategy for supporting students in doing this that we call our challenge cards. And specifically, we have them use these challenge cards with the citizen science data set. So it's still sort of data with meaning and context that they can connect to.
Another quick note,
Yep.
the challenge cards actually were developed, we developed them in collaboration and working on a project with folks from Turk and MMSA, and I think Tracy, I saw Tracy's on the call, and so these challenge cards are something that might have been shared at a previous webinar by Andy, I'm not sure. But at any rate, I just wanted to note that.
And we developed the cards with the idea that we want students really leading the way in developing comfort and skills and facility with the tools, especially because we know a lot of times students will pick up or be more comfortable more quickly with new technology tools than teachers will. So we are going to spend some time going through these tools together, the cards, just to sort of get a sense of them. So first I'll explain how it works, and then we're going to give you a few minutes to try. So if I were a student in a classroom, I would have these cards that you see on the screen cut out.
And just to note, sorry, the cards are on the right, and imagine that what you see on the right that says the round one is a card, and the left is a piece of paper that's not a card.
Yes, thank you, Christine. So they would be cut out and folded, so I have a challenge on the front, a hint on the back for how to complete the challenge. And I divide these cards again among members of my group, and we would each pick a card, work on it for a little bit. If I figure out how to do it, I can move that card into this I did it pile. If it's something that I find really hard, I get stuck on, I can move it into the I'm stuck pile and move on to something different. And you'll see that there are multiple rounds here. And so at the end of my round 1 cards, which you probably noticed are really pretty basic and easy, my team and I, we would pause for a moment and we'd show each other really quickly the new tools that we learned. And we would take a moment to go through anything that was in that I'm stuck pile. But we are all joining virtually here, so teamwork in this scenario would be a little bit complicated. So we're going to have you go through the cards on your own, and Molly sent the link to the data set. And we will progress through slides with the different cards on them slowly. So when you're ready to move on to the next slide, just type in ready in the chat box and I'll move through them once I see a couple of readies. I know a lot of you are already pretty familiar and comfortable in CodeApp, and so for those of you too, I invite you to share in the chat box ideas for additional cards. And for those of you who are learning the tools, if there's a card that you get stuck on, type those in the chat box too. So we'll give about between 5 and 10 minutes for going through the cards. And again, when you're ready for the next screen, type ready and I'll move through. All right, so we're going to jump back in. I'm going to unshare my screen for a moment, or stop share. And I'm wondering if there's anybody who discovered a tool or something new and fun that they could do with the data. And if so, feel free to just jump in, share your screen, and show us.
Or you can also, if you don't want to share a screen, you can also type it in the chat box too, if it's something that you can type.
I see it.
Possible to share code app documents too. For those who don't know how to do it, I can demonstrate. Let's see. So I'll just go ahead and demonstrate that for people in case they don't know. And
Thanks. Annotating the graph was something liked. And maps.
This is my messing about, as Phil would like to say. And if you'd like to share your code app document, go here to share. I don't know why it's not. Oh, okay. Sorry, it's hard for me to see because I couldn't really see you guys. And then go to enable sharing. And then you can just copy this link into your Zoom chat box.
All right. And we know this is a very small, teeny tiny subset of things that you could turn into challenge cards, mostly designed around things that we want to encourage students to do with this data. So if you have ideas of new things to add, please jump in or add to the chat box.
And there's a comment here from Deanne as well about using the photo tool in the oval shape, but then I also thought noting or asking a question about large data sets. And I know Bill or someone from Concord could probably answer that question about the size of data sets.
So with Chromebooks, classroom model Chromebooks, about 5,000 is many data points as you want to go to. With higher end computers, 10,000, I routinely work with 20,000, but it really depends on the machine.
I also see a question about whether these cards are available, and they are part of our curriculum that is shared freely and widely, but our curriculum platform with the rest of our site is not ready yet, but we would be happy to share.
Yeah, our email addresses are, we can, at the end, we can make sure everyone has our email addresses.
Yeah, and so feel free to reach out and we'll send you a copy. All right. Were there any cards that anyone got stuck on that we should go through real quickly before we move on?
No, but a quick question for you, Meggie.
Mm-hmm.
I love the idea of giving these cards to students because we know that they will take off with code app much faster than the teacher. And the question is, how do teachers feel about it? Or were these handpicked teachers that were already comfortable with code app? In other words, they could get left in the dust, and what does that mean in terms of their ability to interact with students around the data?
That's a great question, and we'll get into it a little bit later, and the answer is yes. So very mixed responses. We've had teachers just sit down themselves and go through the challenge cards as a way of feeling ready. We've had other teachers just sit down next to a student and watch them figure it out and, are comfortable with that, amount of letting go. And then there are teachers who are not at all comfortable with it. So that's something for us to keep working on.
One of the examples from this fall, and in fact, it was the students who collected the data we were working with as class data. Their you know, that, oh no, sorry, it wasn't that group. But at any rate, there were 2 classrooms in the same school working on the pilot. And one of them got to using the challenge cards and CODAP first. And then a few of those students ended up going into the other classroom to share their expertise with those students. So the second group didn't use the challenge cards, but they learned from their peers. So I thought that was a cool process.
And there's actually 2 comments that came in from Dan here in the chat. So he loves when his students get ahead of him, particularly with tech, because they often explore and identify new features they weren't aware of. And I feel like we see that all the time. Also, there was a card that they got stuck on. So it had to do with adding a series and didn't see really how to do that because it was blocked. So I'm not sure if we might be able to figure out which card that was and show that real quickly.
Adding a series.
While Meggie is ruminating on that, I was just thinking about also the first time we used the cards with students, was it? At any rate, when we use the cards with students through the Data Clubs project that we're working with Tracy and Tracy on, I do recall a student discovering a different way of doing something than what we had asked them to do, then something that was different than like the hint on the back of the card, but got them the same result. So that was just to echo what Dan said, that they really do figure things out and teach you things. And I think your expertise, doesn't matter how expert you think you are, they're going to figure something out that you didn't know.
All right. So, sorry, I was looking for the adding a series, and what I found is the add a layer. Is that where we were stuck? Yeah.
Yep.
Yes.
Okay, add a layer. I was going to say, I would love to put it out to this group as I would if we were in a classroom. Is there somebody else who can share their screen and show what it looks like to add a layer?
We are giving participation grades at the end of the webinar.
No volunteers.
Well, we can.
Okay. I don't have it pulled.
So
So,
the link.
okay. Why don't we do it?
Okay, so
Right.
okay,
Oh,
so
sorry, go
I'm
ahead,
gonna
Molly.
share my screen and Maggie's gonna narrate while I do that. How's that? Okay. Everybody see it? All right.
All right, so Molly's going to make a graph. And let's say we wanted to know, she's going to pull in the number of green crabs per quadrat into one of her axes. And she wanted to know how that divided up among habitats. So she's going to pull the habitat over here. And then in that, those habitats, she wanted to know something about the substrate. So she could also pull a layer onto that graph to show the substrate in each one of those habitats. And there we've got it. So that layer is just that's color code on top of your graph to see a third attribute.
Okay.
All right. All right. So I'm going to share my screen again if I can find what I want to share. Hold on just a second.
Did the trick, Sam said.
Great.
Okay, awesome.
It seems like
Are we
some
trying to
people
get
had
back to the
similar
presentation?
Yeah.
things they were getting
Okay,
stuck
thanks.
on that layer one. So I'm glad that we were able to show that.
Awesome. All right, sorry, just a little slow to get back to our slides here, and then we'll get rolling. We're on the question slides. All right. Speaking of being super comfortable with technology all the time. So now that we've had some time to dig around with the tools of the data, it's time for us to start making meaning from it. And where we want to start is just to get a sense of the data. So this is not what the data that includes the data that we collected, but also includes data that we didn't, that other classes from across the region collected. So we want to know where it comes from, when it was collected, what habitats. So we're going to have a sort of more open exploration. And what we want you to do is just choose one or two of these cards to try and answer the questions with the data provided. And so again, we'll give you a few minutes to play around with the data. You can choose any of the questions to see if you can answer, and then we'll share some thoughts after about 5 minutes. All right, so we're gonna mute ourselves again and feel free to play around. All right, so I see some cool conversation happening in the chat box. Does someone want to jump in with anything interesting that they saw in the data or anything they want to share? And again, you can share your screen or share a link to what you've done in CodeApp. So Molly's going to stop her screen share, and let's see what you guys found. So as people are thinking about if there's anything they want to share, I will address there's a question about unidentified crabs. And just to provide a little bit of context, that's just if students are not able to ID the crabs, they go in as unidentified. And we do not have students measure or sex the crabs that are unidentified.
And I think the other part of that too is if they're under a certain size, and also hard to identify or not measured or not sexed either.
Okay. All right. So then I saw another question about the protocol to say a crab is identified. And that's, so we provide ID resources for students in the field. And if it's just not clear based on the resources that they have, then the crab is labeled as unidentified.
And it's almost always very small crabs.
All right, so shall we keep moving on? Oh, sorry.
I just noticed that Lynn was having a hard time changing kind of the layer. I don't mind sharing a screen to show what I made a graph of since we didn't get other volunteers. Is that worth it?
Yeah,
okay.
Go ahead.
Great. I was trying to answer a couple of Meggie's questions at the same time. So I started by looking at the size, and so I can just I pulled the size down to my axis, and then I did the same, and then I was curious how it divided up across the different types of crabs, and then I wanted to see if it was different between, male and female. A very sensitive trackpad right now. And then Lynn was having a hard time getting it to change that layer, and so I just wanted to show that if I dragged a different layer, I could just change it that way. And I'm not sure, Lynn, if that's what's not working for you. I'm not sure why it wouldn't work. I should be able to do it with any of the categories, any of the attributes. So, work now. Stop sharing.
Okay, great. So we're going to go back into our slides, and feel free to keep poking around that data. So after this sort of open exploration, getting a sense of where the data comes from, then we would, the next step would be to look back at our research questions and use the data to compare across regions or over time. So our questions are about how abundances compare up and down the coast, how they compare over time and in relationship to climate change. Now, as you saw, this is a very small data set from 4 classes from just one field season. And so we don't really have the data to adjust those questions right now, but we can begin engaging students in just comparing distributions. We use county as our proxy for region, as that seems to be the easiest way to be able to look at data across region. And we'll talk a little bit more about some of the challenges in getting to these larger investigation questions with this data set in just a little bit. But the pieces that we see as most important in working with this larger data set is that students are doing this exploration, they're learning these tools all in the context of data that means something to them. And that they've had the time before getting to this point of moving from they're thinking about just one data point that they collected and contributed to a small data set to a larger one. And they're working with this tool that allows for really easy and open exploration, and then moving towards these really big and complex questions in this large data set at the end.
So I am going to quickly share just one structure that we're using in the curriculum that supports these strands and themes that we're pulling through, both in connecting students back to their background knowledge. And
could I ask a question first?
Yeah, absolutely.
So you organize the data in this hierarchical fashion. Is that what the kids see also?
Yes, yep.
And do they have problems with that? What problems do they have, I guess?
That's a really great question. And it hasn't come up in any of the survey responses from teachers or students, and it hasn't come up in conversation yet, but that's something that we'll definitely be on the lookout for as we start getting feedback from the spring pilot.
We have done a couple Zooms, or Meggie has done a couple of Zoom screen shares with students just while they're working. She's lurking and they're working through the challenge cards and in CodeApp. So I don't know, it hasn't seemed to come up.
Which isn't to say that they understand the organization of it. I think it seems like it's just what is the thing that I'm looking for? I'm going to go grab it without really paying attention to the organization of it. But we intentionally had that set up for them ahead of time to make working with the data a little bit easier.
Yeah, I mean, to piggyback on Bill's question, we've found in classrooms that, the equivalent of reading and writing is important. So in this case, they're reading hierarchy, right? So data at different hierarchical levels. And that if you ask them to produce a data table with a new hierarchical level, that may be a completely different thing. So if they're creating the table, that's very different than reading the table. So I'd be really curious, if you have them create levels of hierarchy, what their results are. We've had trouble in high school with that, which is, I don't know, Bill, if that's where you're coming from.
Well, we've done research about whether kids of this age actually can understand, can make sense of the hierarchical structure. So they're not just using the data, they're trying to explain to an interviewer what's going on. And we find that middle school students fairly quickly can understand that structure and explain it and make use of it to investigate questions as well. So I was just kind of looking for a counterexample or confirmation or something from you guys.
Well, Bill, that's a kind of the thing that just popped into my head is that we aren't learning researchers. If you want to do a project researching that in the context of this work we're doing, we would be excited. I think in general, we have been trying to sort of make it sort of seamless for students so that they, the sort of low barrier, and that the thing that their kind of mouth is watering for next is there and ready for them. So we've tried to sort of only have them constructing things as it's useful to moving them to the next step. Does that kind of ring true to you guys?
Yeah.
Should I go on? Okay. So again, just to reorient you, that we want to share one structure from our curriculum that we're using, that one of the ways we're specifically using it is to in support of the learning progression is to continually ground students in the research question, in their background knowledge, and support them in kind of pulling all the pieces together. And this is our student notebook. So each lesson in our curriculum has companion student notebook pages, and they're parallel in structure in that they all start with the do now, which is going to, again, sort of trigger some background knowledge that they'll use during that lesson. It might also just ask them to do something useful, like get out the materials they will need. But so it starts with the do now, and then there's a chunk of directions and questions that are unique to each lesson that are based around the activities of that lesson. And they all end with a reflect and think ahead. And that is going to connect them back to the larger investigation question and thinking about where they're at and what they did today contributes to going forward. And then each one also has a rubric that students, teachers can use to orient students from the beginning about what they're going to be doing and getting out of the lesson. And then students at the end use it for self-assessment. And then teachers use it for assessment of student learning at the end of the lesson. So that's the structure of our student notebook pages that we're excited about, and that Maggie's going to share some student work examples that will include notebook pages. So we wanted to orient you.
So we collected a lot of feedback from our pilot classes this fall and are doing the same this spring, and we're learning a lot really fast. And so we thought we'd share some very early learnings and questions and ideas that have come from that feedback. So we collected feedback in the form of exit slip surveys from students, teacher surveys after key lessons, teacher interviews, and we had teachers submit just a small handful of student notebook pages at the end of the investigation. So there were generally around 100 to 150 student responses after student responses in the exit slip surveys. We had anywhere from 4 to 11 teacher responses and from their surveys, and then have piles of student notebooks that are probably about 50 different samples of student notebooks that we're pulling from.
And the surveys were from after each. There were key lessons we asked all the pilot teachers to do with their students, and so they had these exit slip surveys for students and feedback forms for themselves to complete after each one of those key lessons.
And then at the end of the experience, we conducted interviews with each of the teachers that participated too. So our big takeaways, our first one is that we found that this citizen science mission is really an engaging context for working with data. In teacher surveys, 85% of teachers responded that students were aware of the purpose of their work, and we found that in student responses they were able to identify what their mission was, why it was important, and who was using the data, which hasn't always been the case for our citizen science work in the past. Around 75% of students reported that they enjoyed working with the data and were looking forward to the next steps in the investigation. And this number stayed the same from looking at the small class data set and then also working with data in the larger citizen science data set. And then in the interviews, teachers repeatedly talked about just a high level of engagement in their classes that they were really excited about. We found that even though teachers, for the large part, were not used to constructing distributions as part of their science class work, that this seemed to be pretty accessible to students. So we found that students did not really struggle with constructing or understanding distributions of the small class data. So in their work samples, they use their own informal language to describe the distributions. And you can see that they're able to connect what this, they're able to connect the distributions to the work that they did out in the field in their responses, explaining some of the variability. And the examples we pulled here, you can see sort of what we expected to see in terms of how students explain variability. And their first response is always, you know, some people looked harder, or my friend was goofing off. But in almost all of the responses, they did also get to a point of acknowledging natural variability as well. So wet spots versus dry spots, or distance from the water line were cited as sources of natural variability. In the survey feedback, around 85% of students self-reported that constructing distributions and understanding them was not a challenge for them. So then we found our challenge, and surprise to no one, was supporting students in working with a larger data set. So these responses, and we mentioned this with Tom a little bit earlier, that responses from students and teachers just varied a lot here, which we're actually encouraged by, and we see that as sort of a sweet spot that we see that we can really focus work here and kind of make a lot of progress. So one of the major challenges in our fall pilot was that students were working with new protocols, and so we didn't have a larger data set. We didn't have existing data that matched the data that students collected. We did have our existing data set from our old platform where all of the data was just presence absence data. So I put some screenshots up of what that looked like. So it wasn't the abundance data that students were used to looking at. And they had a really hard time understanding the presence absence data and what that meant with respect to their investigation questions. And they jumped to a lot of conclusions very quickly that were not supported by the data. Mostly that more data points meant higher abundance of crabs. And working with the tools, as I mentioned to Tom, the teachers had really mixed responses in terms of how comfortable they were in letting students take the lead and using the tools themselves. And then they also had mixed responses in terms of how easy they felt it was for their students. So some teachers said it was no problem, the kids picked it up quickly, and others said that students really struggled. 65% of the students reported that using the tools was not a challenge for them, was easy. 70% of the students said that using the data to answer the investigation questions was not a challenge. But then again, that meant that it was really easy for them to make some, pretty dubious claims with, with the data that they had. So as we move forward with our spring pilot and the responses coming in, we have some really big questions that we're really excited about diving into. So the first big question is, now that we have a little bit of data that is closer to students' experience, will they have an easier time working with that data in the larger, the context of the larger data set? So the other question, though, is that it's going to take a long time for us to develop a data set that is really robust, especially with a number of different missions that we have. And how do we support students while this data set is building? Will it feel like a meaningful experience to engage in this full investigation when there are no clear answers at the end? And how do we support students in really sort of thriving in that environment of uncertainty and engaging with that uncertainty and seeing that as a productive thing? And that's something that we're really sort of excited to think about and even hear some ideas from you guys as well. But overall, we feel like we're moving in the right direction. in the final survey for the entire investigation, all of the pilot teachers reported that the new experience supports data learning effectively, and all of the teachers but one, who is retiring next year, said that they will definitely repeat the experience. So that's the early feedback that we have.
Okay. Questions?
So at this point, we're ready to open it up for questions, discussion.
I have a question. Do the students get to see their data added to the building, the data set that's building, or not?
And so in the old technology platform, yes, you know, they would immediately see it come up in the database, and it would be marked as not yet reviewed by the expert. So that's part of the system that we're still building in the new platform. But you know, our intention is that, similar to previously, students are contributing data that they see themselves are adding to a live data set. We just don't have that functionality live yet.
So how do the data get validated, or how will they get validated?
So each of the researchers who are using the data will have their own account, so their own access to the data, and they'll be notified when the data are submitted. And then they'll have the ability to go through each data sheet and then quickly either confirm or question the data. And then any data that is questioned will not be included in any sort of roll-up or visualization of the data on the page.
I'm guessing it won't go back to the students to,
right.
Yeah.
Mm-hmm. Mm-hmm.
And so I was just going to note that, again, historically, we've had this presence-absence data that an expert validates the student claim that they found or did not find what they were looking for based on the photo and written evidence. Students could also contribute different habitat data, but none of that went through the same validation or review process. So in the new system, any data that the system that is put into the system is put there because it's useful to the scientists, and it all will be validated or reviewed by the scientist. It's going to.
I was struck how few native crabs, I think just one native crab in this data set. Doesn't that make answering the research questions kind of problematic about invasion?
I think it brings up a lot of good, or it has, we've seen it bring up a lot of really interesting questions. One just about where you're finding native crabs versus invasive crabs, and also, since this is happening all along the coast of Maine and then in other areas, further south too, people are really wondering, will they see major differences? But, these invasive crabs are in pretty large amounts all over the coast so far. So it brings up a lot of really interesting questions for further research.
And part of the background knowledge building, students, native crabs actually tend to be more subtidal. So that's part of something that they'll learn, that just naturally less likely to see those in the intertidal. But there's also multiple invaders, and we have this kind of historic green crab invader and Asian shore crabs, which, just anecdotally, I grew up on an island in Maine, and we did not see Asian shore crabs when we went crabbing. So it's part of what's interesting that might change would be the abundance of different invaders. Mm-hmm.
And also abundance each innovator over time, right? That we're seeing sort of wild differences in abundance in different areas and in different years, which is really interesting.
Part of the curriculum that we didn't talk about or model is also each unit includes a lesson that where students engage with climate data, looking at 30-year data sets, 30 years worth of a relevant factor, such as winter minimum temperatures. And I'm kind of looking at Meggie because she made those data sets, so she knows what the factors are.
So it's localized climate data for each county along the coast. And for this particular mission, they look at minimum winter temperatures for the last 30 years. And that was suggested by the researchers that we work with as being low winter temperatures as being seen as potentially sort of a hold on the green crab population in the past, whereas it's not seeming to have the same effect now.
So one of the characteristics of doing data science in the classroom is this feeling of being awash in data. And do you have a comment on to what extent with this larger data set students experienced it as large?
I think in this context, large might be relative. So there's your comment about moving students from my data to statewide data. So that might be part of the answer.
Yeah, I mean, I think part of our goal in the progression is that they're always asking for the next thing. So I don't know that we've heard that sentiment, and I don't know if it would, if we're achieving our goal, I don't know if it would be the exact sentiment that they would have, but I think it'd be interesting to dig in around that.
Yeah, a similar question, and I think this is more of a kudo, more of a statement than a question maybe, but in the beginning you showed the kind of graph, the progression of like data learning over time from kind of small data to Mondo data. And it seems like you're really doing it. It's like you've done a thoughtful progression of how students collect and ultimately analyze their data and others' data in a really careful, thoughtful way. And it's really interesting to see. So I'll be interested to see how vital signs moves in the future. I guess that wasn't a question.
Well, we hope we're moving in that direction at least, Tom.
One thing we do have to say sort of in all transparency is that there was a little bit of fall off in the end in terms of engaging with data analysis in the fall with our pilot teachers. And that's been a struggle throughout the existence of Vital Signs. And you know, a lot of that just had to do with running out of time in the fall with report cards, right? And so that's another piece that we're still very much engaged with and figuring out is how to really support moving through that, you know, entire progression and sticking with it.
The kind of more glass half full view of it. And I feel like Tom would appreciate this, having seen this program since its infancy, is that actually largely, you know, so many of the pilot teachers did follow the full lesson sequence and use the curriculum and do the lessons we asked them to do, which is kind of like, what? So, you know, so I am hopeful that we've got the makings of something good for supporting that kind of learning. Yeah, we just need to make it so that more teachers can fit it into their year.
I think another kudo, there's a frequent critique of citizen science programs that the citizens, in this case the students, contribute data, but they don't get to do anything with the data. And you really broke through that. So it looks like, you know, a major portion of what you have here is students working with the data and trying to draw conclusions from it.
Yeah, I think I kind of maybe skimmed too quickly through some of my talking points earlier, because one of the things I did intend to say was that that's always been our goal and our vision. And I say we, there's other folks sort of participating in the webinar who, are founders of this program. If Sarah's still there, it was always the goal that students would go beyond data contribution and they'd engage with the research questions and they'd work with the data. But these are the kinds of things that we've been trying to tweak and play with all along. How do we make that really happen? And historically, we had a curriculum bank full of resources to support it that teach, with the idea that teachers would sort of design themselves what that learning sequence looks like. And that does work for some teachers, but I think what we found over time is that teachers really need the model. And then once they have a model to work with, they can tweak it. So that's why we've really zeroed in on creating mission-specific units that lay the pathway out and give teachers that model that they can use and then tweak and redesign from there.
As a software designer, I'm wanting to know if there were things that you wished that CodeApp could do that it couldn't do.
I've been asked that question before, and I don't have any specific answers. There was a point where I remember typing something in the help forum, and then all of a sudden I was able to do what I needed to do. But I mean, as you saw, we're not doing too many very complex things in CodeApp. It's pretty basic and I think really user friendly.
I think the ease of using it, and both on our end and on teachers and students' end, has really opened up our ability to kind of get people past that barrier of thinking about working with data in the classroom. So so far, it's really just been a huge asset.
Yeah, the one thing that comes to mind is that being able to make font and things bigger.
Yeah,
we've had some teachers kind of not being able to see it, but that's a cosmetic thing.
Well, it is a problem, though. And do they know about increasing the magnification in the browser?
Yes, and I think that did kind of create some challenges.
Other problems, yes. Mm-hmm. Mm-hmm.
I have to say that watching students, in my position of lurking remotely, it was really, really fun for me to be able to see students explore in data, right? That when I was a classroom teacher, we did most things by hand, right? And that position of sort of not knowing where to start in terms of how to answer a question with data, playing around and seeing, oh, this doesn't really make sense. This doesn't get me where I want to be. Oh, okay, now I understand. And just that ability to be able to play in a way that's, very, low consequence for making mistakes, I thought was really, really fun to watch.
Back in 2013 or 2014, I can't remember now, whenever we did our very first data-focused teacher PD around our first data-focused curriculum unit, I remember there being a specific conversation where, first of all, teachers didn't know what dot plots were, which I think that there are a lot of people that are, and this included teachers that teach high school science teachers that were teaching really advanced classes. And anyway, I think there's been a lot of work where we don't see that as much anymore. Teachers are more familiar with dot plots. But also the conversation was, even to create the dot plots for that session, I had to create some, hacks in Excel that I got off the internet. And part of the conversation with that group was that using spreadsheet software, teachers and students weren't comfortable with it. So I'm not trying to be an advertisement for CodeApp, but since that time, we've tried different, technologies that have become available since then. And I think we're happy to have landed on CodeApp for this stuff. So just a kudos back to you guys.
Yeah, big time kudos.
Yeah, definitely.
People are so excited about it when, wherever we go.
Were there any questions that folks had that we didn't answer? Something we missed in the chat box, or?
I haven't seen anything so far. On that note, I'm fine ending a little bit early if the rest of you all are, but just wanted to double check that that's okay with you.
I do have one kind of perennial question, and I may have asked this recently and I've forgotten. That again, the use of data on a map is really different in the same way like we're describing dot plots is really different, which seems confounding but true. So where are you as a project or a program right now on map of focused on Maine, New Hampshire, and looking to the future and potentially using vital signs outside of Maine, New Hampshire? Like what's your current thinking?
So the vision, and Sarah should chime in as well, but is that, the program and the citizen science platform, when we relaunch in the fall, it will be a regional, regional citizen science tool. And so I guess I'm not sure if that's what you're asking, if you're asking about sort of the data work that students do in maps. I think regarding that, while we'll have, maps in our system, most of our curriculum work around working with the data and the more technology, doing more manipulation will be in spaces like CodeApp. So it'll be dependent on what those tools enable us to do.
So I guess I was thinking, so there's software limitation, right? So you need the actual geographic location, if you're going to be in Texas versus Maine, and there's that. But then there's the logistics of the program of, because you're a citizen science program and you connect with very specific scientists to contribute very specific data, then there's a whole curation of, students to experts, which is huge, right? So just kind of curious so you're saying the plan is to stay regional. Hi, Sarah.
Hi, Tom.
Oh, nice question mark.
I know, it's actually an exclamation point, as you would know, but
yeah.
It's about being excited to be on video calls all the time these days. As Christine said, we really are, with this new platform, and in large thanks to her, our new common theme focus of the new Vital Signs and Citizen Science platform is looking at changes, climate-related changes, so changes or impacts on species, habitats, and ecosystems throughout the Gulf of Maine watershed and the Gulf of Maine. So we're taking a geographic focus and supporting these projects that are designed and supported with the incredible curriculum and resources that we've just spent the last while going through, but also projects that are created by communities within that. So it's not just going to be projects posted by scientists, but projects that are posted by communities who are wondering what are they going to do about X, Y, Z, or how is climate change impacting the things that they care about. And in creating those new projects, we're going to provide resources and consulting support to help those projects that get spun up be high quality and represent the kind of thinking that you've seen today. Does that better answer the question?
It does, actually. And part of this is selfish, as many questions are. So I'm thinking about the Gulf of Maine watershed, extending down into the bay outside Boston, and Massachusetts students, and whether there's geographic access to students from Massachusetts. And part of the reason I'm asking is because of the research capacity of the Concord Consortium.
Yeah, and we would love to fully occupy the Gulf of Maine watershed, and we're really interested in looking at kind of the bigger picture, and we're not entirely sure how this will go, but we're hoping that it emerges. The idea is to look and develop stories about change in all the different parts of the Gulf of Maine watershed, thinking about that as a system and its relationship to the Gulf of Maine, which we know is warming faster than 99% of the global oceans. So what's happening in the watershed, and what can we learn about the system by looking at the different kinds of change, the pace, the scale, etc., throughout that space. So we would love to fully occupy that geographic space from Massachusetts all the way up into our friends to the north in Canada. So I'd love to work with you on that, Tom.
And Tom, I think you'd appreciate that. I just realized that every time one of us speaks, Meggie's face comes up because we're using the audio.
I love it.
It took me an hour and a half to realize that. So we are, all the missions that we'll be launching in the fall. There's no geographic barrier on, participation in those. So classrooms in Massachusetts will immediately be able to participate. Our, range of our teacher professional development offerings will still probably be pretty limited for a while, but the system itself and the opportunity will be available to classrooms. So, and just to reiterate what Sarah's saying, or another layer of it is that, some of these projects will be targeting classrooms and some will be targeting,
individuals
across the communities.
I want to go back to student learning again for a moment. Several times it's come up in the conversation here that it's unusual to have map data and other kinds of data integrated. And I wondered if you observed students making use of the map and what you found about their ability to make sense of what they were seeing in the map and the extent to which they linked it to the other data, I guess.
So the students use the map quite a bit in using the presence absence data from our old database, right? And that was really the easiest way to engage with this, question of where are these crabs found and where are they not found. It's a more complicated in CODAP now when you have one location that then has this whole range of abundances, for that one transect. And so figuring out what are the, most useful purposes of the map in that context, I think is a little bit more complicated. But yeah, they went immediately to maps to address questions just along the lines of, where is the data from, where are the places that don't have a lot of data.
And just part of that, figuring out how to use the maps is connected to us figuring out the right kind of roll-ups and report-ups of the data, which is another piece we're working on that, I think will be connected to our species expert or, project owner validation process, and will be connected to kind of what kind of spits out to other systems and things like CODAP. So part of that for us is figuring out what could you view on a map that would be helpful, and how can we roll up the data in a way that we can do that. And that will be different for each project.
I feel a natural ending.
Pretty. Well, I guess that's my cue then. I can see that people are wrapping up on chat too, which is great. Let me go ahead and wrap us up here. Maximize window. Okay, great. Well, I had such a terrific time on this webinar. Thank you very much to the three of you, Meggie, Christine, and everybody else. Also to Molly as well. Thank you. Thank you, everybody, for joining us today. If we did not get to your question or you'd like to leave additional questions or comments by Twitter or email, please do so, and we'll respond to you tomorrow or as soon as we can. We had a lot of great interaction. I'm grateful to you to making rich discussion happen, especially at the end. That was wonderful. We'll send you a link to the recorded session shortly. You can sign up for our next webinar and future webinars at concord.org/meetup. You can stay connected with us on Twitter at CODAP If you use the hashtag DataSciEd to tweet us any additional questions or resources, we'll be sure to respond to you. Please feel free to visit our website, codap.concord.org, to connect with us as well. Thank you all very much, and I look forward to seeing you next time.
Thanks, everyone.
Thank you, everybody.
Guys.
Bye.
Thanks, everyone.